Hey guys, welcome to my channel. How are you guys doing? So today's video is going to be on 5.2, just a continuation of 5.1, which is understanding like terms and unlike terms. So let's get started. So our definition here, we're going to start for like terms. So terms in an algebraic expression that have the same variables raised to the same power can be called like terms. And these can be collected through addition or subtraction. So unlike terms, so these are the terms in algebraic expressions that have different variables or powers. So these terms cannot be collected or combined through addition or subtraction. So let me show you guys what I mean. So for example, for like terms, this 10x and 2x, these are going to be considered like terms. Why, you guys may be asking? Because look, this is both 10x is to the power of 1 and 2x is a power of 1. So the x's, since they're both to the power of 1, they're like terms. It's not like the 2x squared is to the power x squared, because that would not be considered. And I'll show you down on why that is unlike terms. So you guys might be thinking, oh, but this is a 10x and this is a 2x. They can't be like terms. See, remember guys, in the last video, this 10 is a coefficient and this 2 is a coefficient. The coefficients don't matter as long as the power is there. If the power is the same to the power of whatever it is, then it's considered like terms. The coefficients are simply just like saying like 2 plus 5. That's going to be 7. So that doesn't really matter here. The next example here is y squared and minus 5y squared. So we have our variable y and y. We can see that this is also like terms because the y is to the power of 2 for both of them. So if you guys also want, you guys can also highlight this so you guys have a better understanding. So these two are to the power of 2, hence why they're like terms, and this coefficients here won't really mean anything unless when you're counting like terms and you're gonna solve it and make it simplified, then then the coefficients come into play. But other than that, the like terms are because the y is to the power of 2. Now, unlike terms. So, unlike terms, basically, like I said, is powers that do not have the same power raised to whatever the number is. So, for example, over here, we y minus y squared and 5y are not like terms because you can see here our y squared is to the power of 2 and our 5y is simply to the power of 1. 2 and 1 are not the same powers. They're not the same numbers. Hence why this is an unlike term. For the second one, which is x to the power 3x squared, 3 and 2, again, these powers are different. So 3 does not mean 2. So this is why it's going to be unlike terms. Same one for this. The x and the y, they are completely different variables. You can see that they're both to the power of 1, but x is not y and y is not x. These two are different. Even the 3 here is the same, but since the x and y are two different variables, y cannot be x, so this is also going to be unlike terms. So remember, only if the power of the variable is the same and the variable itself is the same, then they're going to be considered like terms. So let's do some examples so you guys know what I'm talking about. So identify the like terms in the expression and combine them. So if you guys also want to do like a different marker to help you out, it will also be easier for you. So here we have 4x. So we have to just look for another x with the power of 1 in this whole equation. We can see here this minus x is the same. So we can put this together as 4x minus x. Now we still have our 2y here and the plus 5y. So now we have to look for the y that has the power of 1. That also, there's another y that can have a power to the 1. So this 2y, so it's going to be 5y. And we can see our 5y is also to the power of 1. So this is going to be a like term. So this is going to be plus 5y. Now we're going to be solving each of them. So this 4x minus x, so this is going to be 1. So when it comes to solving down, then you don't have to worry about the exponent and the power too much. All you have to worry is about the coefficient. So 4 minus 1 is just going to be 3, and you can just leave the x by itself. You don't have to do anything to x other than just write it down. 2 plus 5 is going to be 7. So this will be 7y. So this is going to be our final answer. For our second one, we have 7x squared. So this here is the power of 2. Can we find another x squared in this whole equation? Yes, we can. We have this one over here, which is also to the power of 2. So we can start off writing it as x squared minus 3x squared. Now we have a 5 here. This doesn't really have anything to power. This is just going to be a single number. So can we also find a single number in the equation that also has no power? Yes, we have a minus 4. So we have plus 5 minus 4. So we're done with that. Now we just have this 2x. So there's no more 2x's or x to the power of 1 anywhere. So we can simply just write this as 2x. And now if we were to solve this, 7 minus 3, because we're only going to look at the coefficients, guys, remember? So 7 minus 3x is going to be 4, and we can just simply write the x squared beside it. 5 minus 4 is simply going to be 1 and plus 2x. And remember in 5.1, the order goes from highest to lowest. So this is going to go where the 1 is, and the 1 is going to go where the 2x is. So it's going to be 4x squared plus 2x plus 1. So our third one here is 4m3 to the power of 3 plus 2n minus n plus 2m to the power of 3 minus 5. So starting off with our 4m to the power of 3, can we find another m to the power of 3 that we can combine it with? Yes, we can. We have this 2m to the power of 3. So we can start off writing 4m to the power of 3 plus 2m to the power of 3. Next, we can go look for our 2n to the power of 1. Can we also find another n to the power of 1 where we can combine them together? Yes, we can. We have 2n minus n. Now we have minus 5. We don't really have another number, a single number, so this is going to be minus 5. Now to solve it, we're just going to be adding the coefficients together. 4 plus 2 is going to be 6m3. 2n, so 2 minus 1 is just going to be 1. So this is just going to be n. And the minus 5 is just going to be minus 5. So this is this answer. So this was all for this example and this lesson. I really hope you guys are understanding this. Let me know if you guys are not. I can always help you. And thank you guys so much for watching.